Hello, Brandon Clayton here, the Algebra Guy. Thanks for tuning in. As you see on our screen, the title is Write Quadratic Functions Using Technology to Make Predictions. So this is one of the tips that I think is pretty cool because it has a strong real-world application, because you're going to be given data and you can make predictions based on the data you get. So let's jump into what we want to deal with today. Our TEAC is 8B, right? Using technology. So they actually want you to use technology. This is not an extra thing. Quadratic functions that provide a reasonable fit to data to estimate solutions and make predictions for real world problems. So let's start with star questions. I couldn't think of a better way than to just start with the star questions and how we use the calculator. So I'm going to take out my calculator and we're going to work through these problems together. First problem is this one. A couple of years ago, a projectile is launched into air from the ground. The table shows the height of the projectile. So it's taken based on the table, which function can be best be used to model this situation. So they were taking kind of a picture every 5 seconds about where the height was, and this is what we got. We want to come up with some kind of equation that gives a good estimate along which the path this thing is flying. So let me just kind of illustrate this because I just kind of think this is cool. So if I had this projectile and it was taken off somewhere and you got all these dots kind of moving up here and you want an equation to best fit that graph, the calculator can actually handle that, and it's pretty simple. And I don't even know if it's mathematical really, other than you just know how to use a calculator. So let's jump into doing just that. So let me take out my calculator. If you have one, you can take out yours and we'll work together to see how we would do that. So in order to work this, we're going to use some different applications that we don't normally use. One is a spreadsheet. The other is I always forget the name of this other one. What is this? Data and statistics. So I'm going to start with the spreadsheet here, and I'll open up there. And I'm going to fill this in just like it is on that table. So the first thing I'm going to do, let me go over what I'm going to do totally. I'm going to put all this information in. I'm going to have the calculator plot these points on a graph, and then I'm going to have the calculator draw a best fit line and give me the equation for that line. So that's what we're doing here. And it's not a line, it's a parabola because it's a projectile falling, right? So let's make this first column X and this one B. And we're just going to go ahead and fill in all the information from here. So I went ahead and populated all my information in here. As you see, 5, 10, 15, 20, 25, all the way through 35, and my Y information is filled in as well. Now, we're going to make it X and Y. You could actually put in time and height, but that's not necessary. One little thing I want to tell you is if you're plugging in this information, oh, I just realized this is off, 4440. If you're plugging this information and your box ends up here, please press enter to get off of that box or move off of that, because it won't tally that point and it'll throw your data off and it won't let you complete it. So that's just a little side note there. All right, so what do we do at this point is that we've populated all our points, and now there's a couple things you can do. You can press menu and data and go quick graph to get a quick graph of what this will look like and give you an equation. Or you can actually go all the way back into the home screen and pull up statistics or data. So you can do it from here or go back. So I'm gonna go ahead and do it from here since this right here is pretty convenient. I'm gonna go quick graph, and it's asking me, you know what? Let me see if I can back up, because it's so much nicer when it's bigger for you to see the whole screen. So let me go back to my home screen, and I'm gonna, there we go. So you see all these points just randomly put out here. I'm gonna slide down here to the X-axis, click on X, and I'm gonna slide over to the Y and click Y. And notice what happens. Isn't that beautiful? So it actually lines up and you can see the trajectory of those points. But I don't know the equation, so none of this is gonna help me. Now I could put all these in my calculator and kind of get an idea, but wouldn't it be better if the calculator would just tell us what this is? So I'm gonna ask the calculator to do just that. I'm gonna go to menu, and I'm gonna ask that it analyze these points. I'm gonna go to regression, and I'm gonna look for the parent function that most resembles those points. Either it's a line, a quadratic, or exponential, because those are the main three that we deal with in Algebra 1. So it's definitely not a line. It's not exponentially decreasing. This is definitely a parabola. So I'm going to click on show quadratic. Be careful of picking quartic. That's another kind of mistake that some students will make because it looks similar but quadratic. And notice that it fits very well. Look how that line goes through those points. So I know I have a pretty strong equation, and it automatically gave me an equation. Look at this. Negative 4.899 x squared and all this business here. So now we can probably get a pretty good idea just from these first parts. So looking back at our answer choices and our equation, let's start to mark out. It can't be that first one, and it's not going to be that one. It's going to be negative 4.899. So it's B and C have the same thing here. The only difference is what their C value is. So let's kind of move that over to see what that looks like. All right, so we're going to move this over, and I get all this x plus 0.57. So 0.57 is much closer to 0.6 than it is to 2. So that is definitely the right choice. And how fun was that to do? So we really didn't have to do a lot of math, adding, subtracting. We just had to know how to use technology, as they mentioned. All right, so let's go to our next problem. I'm going to erase this one. All right, so an object is launched into the air. This is from 2013. The table below shows the object height above the ground. Again, we got a projectile. Based on the data, which of the following is closest to the object's height above the ground 9 seconds after being launched? So we could probably make a guess. They gave us 1 second, 2 seconds after launch, 3 seconds, 4 seconds. They want to know 9 seconds after launch. Where's that number going to be? Well, it looks like it reaches a crescendo around here and it starts coming back down. So we could probably guess where it might be. It's not going to be bigger than 137, and none of these are, but we don't know exactly where it's going to be in 3 seconds. We can kind of guess. If that's the middle, let's say this is 1, 2, 3, so maybe around 109. I'm going to guess around here. So because if we went down 1, 2, 3, this is about 110, and I'm guessing 1, 2, 3, somewhere maybe around there. It's going to be the same thing. So let's see. All right, now at this point we want to put this into our calculator. So we're going to go to our spreadsheet here and put in our X and Y, and we're going to input our data just like we did before. 1, 2, and so on and so forth. Got my data in, so as before, 1, 2, 3, 4, 5, 6. I want to double check because if these numbers are a little bit off, sometimes it really messes us up. So it looks like we're all good there. I'm gonna go back to my home screen. Now there's other ways to get to your data than that, but that's just what I'm used to. So I go back to my home screen and I click on this piece for the data and the statistics, I believe it's called. And I'm gonna click down here to make this the X axis, and here to make this the Y axis, and I get again a parabola, which I'm not surprised at, and I want to analyze this regression for a quadratic. And when I do, I'm given this right here, but they're not asking for an equation. They're asking for what happens after 9 seconds. So what do we do with this from this point? The best thing I've thought of up to this point is you simply have to write this down, and we're going to plug this back into our graph so we can analyze it at what happens at 9 seconds. So I'm going to leave this here, and I'm going to write this down and figure out. I'm going to write this on the side of my screen, and if I were you, I would write this on your paper, and then we're going to plug it back into our extra graph so we can figure out what happens after 9 seconds. You can see I wrote this down. Negative 4.9, 107.114. Notice I didn't write down every single digit. You can, and maybe you should, but as you get further down that decimal, it becomes less and less important. But for more accuracy, I would go ahead and write down every single thing, but I'm just going to estimate and get about what 4, 5 or 6 digits after the decimal, and that should be enough for us. So I'm just going to go straight back to my home screen and go to my graph now, and I'm going to put this equation in and try to figure out where what's happening at 9 seconds. So we're going to put in negative 4.9, 107.14 x squared plus 49, or 46 rather, 46.23214, 23214 x plus 36.5. And I'm going to press enter, and there's my graph. It doesn't look pretty yet because we need to zoom. And actually, we don't even have to see it, but I'm going to go ahead and let you see what it looks like, because that's usually what we want to do. We just want to get an idea of what it looks like. So there you go. That's about what it's looking like. So the question is, what's going on at 9 seconds? You can kind of count 1, 2, 3, 4, 5, 6, 7, 8, 9 and see up here about what's going on. But here's a cool way that you can find out for sure what's happening at 9 seconds. If you go to menu and trace, graph trace, so you can press your cursor here and it can trace it. Notice that it's telling you what the points are and the x and the y values at every point. So I can actually trace it and get over to about 9 and get a really good idea. There it is. At 9 we have 54.821. See, I was guessing 110, but actually I should have went down one more and it would have been 55. But what if I didn't want to do that or couldn't do that as easily? Here's another thing you can do. In graph trace, I can literally just press 9. And look what happens. When I press 9, it assumes I'm asking for x equals 9. If I press enter, it takes me straight to that point. Now it becomes really simple to see that at 9 seconds, it's going to be at about 54.8, rounded up to 55 meters. And this one is like it. I want to encourage you to do this one, and we'll work this together. So I'm gonna leave this up here. Let's put this table in and see if we can come up with the equation that best fit this model. All our data in, just double checking here to make sure it matches up with what we got, 4112. And now I'm going to, you know what? I told you I didn't want to do the shortcut method, but now that we've seen how it looks on the full screen, let's actually pull it up. And we'll go to statistics, or I'm sorry, data. Is that the one I want to go to? Let's see, menu, statistics, and quick graph. There we go. So I had to click on my actual data. So we're going to go to quick graph. And see, it's a little bit smaller here. That's why I didn't want to do it at first. But just know that you can use it if you want to. I'm going to click on my Y because that's the easiest one to do. And it looks like my X is already clicked on. But there you go. I clicked it anyway. So now I see all my points. A little bit smushed, but that's okay. I can still see it. And now I can, even from here, analyze this graph. Regression. And this is a quadratic. And see, the thing about this is it's so squeezed in there, but if I needed to, for convenience, I could look at it this way. Let's see if I can see all my number. Almost. So I see that there's a 0.742 x squared. So I really would like to see that number so I can be accurate though. To the full screen so I can actually see it, and that was probably one of the reasons I don't use it as much, because look, if this long thing, it just wouldn't fit in there right and it was driving me crazy. So now this is easier to see. So 0.074 something 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 times x squared. Let's see which ones we know it can't be it. So we know it can't be, we're looking at 0.07, so this is not, this is a positive also, so anything with negative can't work. And this is 0.074, and it looks like they're rounded, so 0.072 is about all right. Negative 0.223, negative point, so I need this right here. This is it closer to, let me make sure I get this whole graph and see that that's an X or not. Okay, it is an X. So I need actually an X value. This one doesn't have one, so this one's going to be the next best choice. And my last number is 272.73, and I got 2.67. So there you go. That's the best model. Notice it. Don't be dismayed by the fact that it's not perfect, because we're doing math and we want a perfect answer. Because this is truly an estimate and a prediction, and they're asking for the best model. This is not going to be an exact number, but this is by far, B is by far the closest. So nothing else is even closer, so that you won't have to pull your hair out wondering if you got it right. And that will do it for us today. So did we cover everything we wanted? Absolutely. We wanted to use technology to provide a reasonable field to data to estimate solutions and make predictions. We made predictions, and we filled that data into our graphing calculators in order to make those predictions to do so. Thank you guys for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.